Well, good morning, seniors, and I made a video for you today. I'm sorry I didn't make one yesterday. I finished wrapping up making my videos sometime around 3 o'clock in the morning, 3:05, and I thought to myself, do I really want to make a video for the seniors? And my answer was no, so I just went to bed. But it is about 10 o'clock a.m. here in the lovely humid state of Maryland, and hopefully I'm going to be back on Wednesday, although sleep deprived. I'll be back by your guys' class period in order to teach you anatomy. Let's get a couple terms down here. It'll be a shorter lesson today, just out of necessity, because I do need to leave at some point soon in order to drive back. But we were talking about epithelial cells, and we said we classify them by number of layers and shape. So let's get into what some of these look like. This is a simple squamous epithelium. You can see that the simple designates that it's one layer, and squamous designates that it is a flat cell. Now, S-Q-U-A-M-O-U-S, you're going to hear that pronounced all different ways. I'm going to pronounce it squamous, but you will hear squamous, and you will hear all other kinds of variations. I was watching an NCIS episode one time, and they pronounced it 5 different ways in an episode, so there's some variation on pronunciation. You have stratified squamous epithelium. Stratified means it's multiple layers of thin cells. That is stratified squamous. Stratified epithelium means multiple layers. And there are those two together, simple squamous and stratified squamous, the flat cells. The next type of epithelium is cuboidal epithelium. You can see cuboidal is very easy to understand because these cells are a cube. And when they're stratified, they take a little bit of different shape than a cube, but still a pretty similar shape. They are not flattened out like the squamous. They are more cube-shaped. You also have columnar epithelium. Columnar are columns. And you have simple columnar epithelium, which are tall columns of cells. And you have stratified columnar epithelium, which is large columns of stratified cells. So pretty much you take, whether it's simple or stratified, and you combine it with the shape of the cell, and then you say epithelium, and that's how you get the names for whatever epithelium it is. And the jobs are often based on the epithelium. For instance, simple squamous, one-layered, flat. These are going to make up your skin. Okay, like an outside layer. You're going to want it to be pretty thin. And so you're going to want diffusion to happen pretty easily. Sweat to be able to get through that simple layer. If it was columnar, your skin wouldn't be that good at sweating, and you could overheat pretty easily. Simple cuboidal, one layer and round. Rounded kidneys use that, again, for diffusion. You don't want your kidneys layers to be too thick, but you want it to be thicker than skin, right? And so the simple layer allows for diffusion. The cuboidal allows for the movement of air and other particles through. There's also some other odd ones. Goblet cells are the technical name for simple columnar epithelium, and they have a name because goblet cells produce mucus, generally speaking. You can see on the picture of the simple columnar epithelium that a lot of them are going to have these fine layers of micro hairs. We call them microvilli. And these goblet cells produce a mixture of fluids, proteins, carbohydrates. Their purpose is to cover and lubricate a free surface. And this is important. You are actually more slidey than you think. Your organs, extremely fluid. I mean, imagine, you get punched in the gut. Joelle does it. No, I'm just kidding. And your whole organs move. They have to. And you don't feel them move. It's not like you can press into your body and wiggle your kidney and you feel it, but it does move. Everything is very slippery, including your heart, your lungs. Your heart and your lungs brush up against each other all the time, and you don't feel it. At least I hope you don't. That'd be very uncomfortable. Deeper layers of tissues are called basal cells. There's a very common type of cancer called basal cell carcinoma, and that's when the basal cells actually develop cancerous tissue. Basal cell carcinoma is, I wouldn't say a cancer that is one of the worst ones, but it is a dangerous cancer that you do want to get removed. And that happens in the tissue that's underneath the free surface. Your skin's top layers, the epidermis, is made of old cells, which are pushed to the surface by mitosis. So as your cells do mitosis, the dead ones get pushed to the top to form a really dead layer of cells. And so you can go like this, and you're actually flaking off dead cells everywhere. Kind of frightening. You don't feel them because they're dead. So really your sensation of touch often comes through the hairs on the outside of your skin and whatever nerve endings are near the surface of your skin cells. These dead cells contain keratin, which is a waterproofing protein. That's a good thing to have, or otherwise your skin would allow some water into your body. And, you could be like, I don't know, Aquaman and go into the water and, you get filled up with water. That would be pretty terrible. You would have edemas everywhere just by taking a shower. Other tissues, sometimes no keratin is produced in cells, leading towards a non-keratinized alive moist epithelium, which is in a place that receives access to the outside of your body. Your mouth's a good example of this. Your mouth is alive, and it's moist, and it's not keratinized. It's not hard. It's not dead. Imagine your mouth being, like, your skin on the rest of your body, dead and keratinized and leathery. That'd be disgusting. And so there is also other reasons why no keratin is produced. Your body does an excellent job at stopping disease at dead stuff, right? Because if, let's say, some virus got on your skin, it's not getting through your skin unless you have a cut, because your skin protects it. Right now on your skin, you have thousands of viruses that aren't infecting your body simply because they can't get in. But your mouth isn't that way. Your nose isn't that way. And so they actually have to create certain mucus and synthesize certain synthases to be able to destroy bacteria and viruses that would enter your body. Stratified transitional epithelium offers the body a stretchy epithelium that conforms to the shape it needs to. So you notice here stratified means multiple layers, and transitional means that it can actually adjust the shape it is. So sometimes it's columnar, sometimes it's cuboidal, sometimes it's squamous. Your bladder is a great example. Okay, if you pee, then all the urine's gone and your bladder is really small. Thus, it is a tall columnar epithelium. But as you drink more and more water, this bladder stretches out, and the cells actually stretch out too. And at a certain point, they become more cuboidal, And then if you really hold your pee in a long time, they become more squamous in how they appear. And that is a stratified transitional epithelium. Pseudostratified epithelium gives a look of being stratified, but it is not. It's actually just a bunch of oblong, odd-looking cells that line particularly parts of the nose. You do have coloring book exercises in order to be able to see those things. Last thing we're going to be talking about today is the different glands. Let me do a time check. Oh, plenty of time. So you learn about the endocrine glands. Those are the glands which produce chemical changes to the body. That would be like the adrenal gland, which produces things like adrenaline and cortisol, among some other things, which makes chemical changes to your body. Your thyroid gland is an endocrine gland, which produces thyroid hormones, parathyroid hormones, stuff like that, out of your parathyroid, which is right nearby. Those work internally. Your exocrine glands work externally. And they secrete things to the outside of the body instead of the inside of the body. And this could be things that help the body out. It could be things that your body doesn't want. It could be things that your body carries out of necessity. And so there's different kinds of glands here. The merocrine glands are glands that secrete without losing cell material. So you see the merocrine glands, they produce some amount of stuff that needs to leave the cell, and then puts it on the outside, but it doesn't lose any cell stuff. Apocrine glands actually lose a little bit of cell stuff. Cytoplasm, the liquid medium of the cell, is lost when it is secreted. And holocrine glands actually have cells that are disintegrated and dying, which leave the body. And your coloring book has excellent examples of each of these types of secretions, and we're going to go more into that on Wednesday. And that's actually where we're going to be leaving off. I would appreciate if at the end of this lesson you would read through page 51, and we're actually going to be doing a lab on Wednesday using microscopes to take a look at the various types of tissues and glands and really be able to spot distinctives between them, because to a trained eye, you can look at a gland or any type of tissue and you're able to tell what it is immediately, just by how it looks, how the cells are arranged, that kind of stuff. That's all I have for you today. Very short lesson, and you will have some time left over, and I'd encourage you to take a look back at your coloring book, take a look at your lab, page 51, and maybe to just work on something else or review the notes that you do have. All right, have a wonderful morning and the rest of your afternoon, and I will see you guys hopefully tomorrow.